Welcome, everybody, to another deep dive. You guys sent in some Wikipedia excerpts on hydrogen, and we are so ready to break it all down for you.
Lots to unpack, for sure.
Yeah, this is going to be fun. Now, I always thought of hydrogen as the sort of, well, simple element.
Simple yes and no. I mean, you're right. At its core, it's just one proton and one electron. The absolute basic building block.
Right, like as basic as it gets.
Exactly. But that simplicity, it actually leads to some really surprising complexity. I mean, think about this. Hydrogen is the most abundant element in the entire universe.
Okay, that is true. The excerpt said something like 75% of all normal matter. That's mind-blowing.
Right. It's everywhere.
Yeah.
But here's the catch. Finding it in its pure form here on Earth, it's not exactly a walk in the park.
So it's abundant, but not really available.
Okay, that's interesting. It's this weird paradox. And it all comes down to how hydrogen interacts with other elements, how eager it is to form compounds.
Compounds, like water.
Exactly. 2 hydrogen atoms for every oxygen, you know the drill. But even beyond water, hydrogen is a key player in so many compounds.
You were just talking about how abundant hydrogen is out there in the universe.
Right, and we can't talk about that abundance without talking about stars.
They're basically giant balls of hydrogen, right?
Well, sort of. They're like giant fusion reactors powered by, you guessed it, hydrogen. They take these hydrogen atoms, and under incredible pressure, they smash them together.
And that creates
Helium, mostly.
Mm-hmm.
And a mind-boggling amount of energy in the process. That's what makes stars shine.
So that's how they burn. Huh. Amazing.
It's the ultimate example of hydrogen's power, wouldn't you say?
Speaking of hydrogen's power, the Hindenburg. Enough said.
Ah, yes, the Hindenburg, a tragedy for sure. And you're right, it's a stark reminder of hydrogen's flammability.
Those pictures just seared into our collective memory.
But here's something most people don't realize. Pure hydrogen, it burns almost invisibly.
Wait, what? But those flames, the photos.
The flames we see in those photos, the massive inferno, those mostly the airship's skin, the other materials burning. Pure hydrogen burning, it's almost impossible to see.
Huh. That's both fascinating and terrifying.
Exactly. It highlights just how different hydrogen behaves compared to what we usually think of as fire.
I definitely wouldn't want to be anywhere near that, visible or not. And to think there's even more to it. The Wikipedia article mentioned something about spin isomers, orthohydrogen and parahydrogen.
Ah, yes, the spin isomers. It sounds complicated, but it's actually a pretty neat concept.
It sounded a little too technical for me, if I'm being honest.
Okay, so imagine 2 dancers spinning, right?
Okay, I'm with you.
They can either spin in the same direction, nice and synchronized, or they can spin in opposite directions. That's basically what's happening with ortho and parahydrogen. It's all about how the 2 hydrogen atoms in a molecule spin in relation to each other.
So ortho is opposite, para is together.
You got it. Parahydrogen, spinning in sync, it's the more stable, lower energy state. Orthohydrogen, spinning in opposite directions, it's a bit more energetic.
And this matters because...
Well, let's say you're trying to store liquid hydrogen, which we'll get into later. That extra energy from orthohydrogen can actually cause problems. Makes things heat up more than you'd want.
Interesting. I never thought something as small as spin direction could make such a big difference.
It's all about energy levels. And with hydrogen, even small energy differences can have a big impact.
We've been talking a lot about pure hydrogen, but isn't it true that we rarely actually encounter it in its pure form?
That's absolutely right. Hydrogen, it's a social butterfly. It loves to pair up with other elements.
Form those compounds we were talking about.
Exactly. We've got water, of course, the ultimate celebrity couple.
Always the showstopper.
Then there are the hydrocarbons, the foundation of so many fuels. And, of course, we can't forget about organic matter, which is essentially built on a backbone of carbon and hydrogen.
It's like the glue holding everything together.
Yeah. In a way, it is. Hydrogen, it's in our DNA, literally. And we can't forget about hydrogen's interesting behavior when it bonds with metals. We get hydrides, which are a whole other story.
Hydrides, yeah, the excerpts mention those. To be honest, that's where I start needing a chemistry refresher.
Well, think of it this way. When hydrogen bonds with a metal, it can actually start acting like an anion. It's like it's adopted this whole new personality.
An anion, like with a negative charge, I always thought of hydrogen as a positive kind of element.
It's kind of a chameleon, that hydrogen. It go both ways. And this ability to become H, it's key to understanding how it interacts with metals, especially when we talk about safety later on.
Ooh, more foreshadowing. You're killing me. Okay, so before we move on, we got to talk about hydrogen's claim to fame, protons.
Ah, yes, the bare proton, H. The tiny powerhouse of the chemistry world.
So that's what makes acids, well, acidic.
You got it. That single proton just floating around without its electron,
Yeah.
it's incredibly reactive. That's what gives acids their punch.
It's amazing how much one little element can do.
Right. From the vastness of space to the intricacies of chemical reactions, hydrogen is involved in it all. Talk about a multitasker.
Speaking of which, we've established that hydrogen is powerful, abundant, maybe a little more complicated than we thought. But how was this all discovered? Let's rewind the clock a bit.
Love a good history lesson. So our story begins way back in the 17th century with a scientist named Robert Boyle. Quite a character.
Yeah, wasn't he experimenting with iron filings and acid or something?
That's the one. Boyle, he was one of the first to really document the production of hydrogen gas, although back then they didn't really know what they were dealing with.
Right, that came later with Henry Cavendish in the 18th century.
Exactly. Cavendish called it inflammable air, which, in retrospect, seems pretty accurate.
To say the least.
But, hey, you got to start somewhere.
Hmm?
He figured out it was distinct from other gases, and his experiments show that when you burned it, you got water.
And that's where Antoine Lavoisier comes in. Didn't he give hydrogen its name?
He did indeed. Lavoisier, he was the one who really put all the pieces together and confirmed that hydrogen was a distinct element.
And the rest, as they say, is history. Though speaking of history, the excerpts also mention something about hydrogen isotopes, deuterium and tritium.
Yes, hydrogen's heavier cousins. They're like hydrogen with extra baggage, same atomic number but carrying some extra neutrons around.
So like same family, different personalities.
Yeah. Exactly. Deuterium, that's the one found in heavy water. And then you've got tritium, the radioactive one, used in things like nuclear fusion.
So even within hydrogen itself, there's a whole lot of diversity going on.
Diversity and surprises.
Yeah,
Hydrogen never seems to get boring, does it?
not at all. But let's shift gears a bit and talk about the future. Hydrogen as fuel, is it all it's cracked up to be? So hydrogen, the fuel of the future. Is it really the game changer it's hyped up to be?
Well, it's got a lot going for it. We've talked about how abundant it is, and when you burn it, no carbon emissions. That's a big deal. But like with anything, there are some big buts involved.
The excerpts mentioned a bunch of different ways to produce hydrogen. That's where I started to get lost.
Yeah, production's a big one. And to be honest, most hydrogen production these days, it's not very clean. The most common method, steam methane reforming, it actually relies on natural gas.
So we're still using fossil fuels. Not ideal.
Not ideal at all. It does produce hydrogen, but you also end up with a lot of carbon dioxide as a byproduct.
Defeats the purpose a bit, doesn't it?
Exactly. So that's why there's this push for cleaner methods, like electrolysis, splitting water molecules using electricity.
Okay, so just water and electricity. That sounds way cleaner.
It can be, but here's the thing. That electricity, it needs to come from renewable sources. Solar, wind, hydro. Otherwise, we're just shifting the emissions problem upstream.
So it all
Yeah.
comes back to renewable energy, no shortcuts.
Exactly. And even then, there are still cost and scalability hurdles. Green hydrogen, it's still significantly more expensive than the conventional stuff.
There always seem to be cost hurdles with new energy sources. Let's say we do figure out the whole production thing. What about actually using hydrogen as fuel? We can't forget about the whole flammability issue.
Absolutely. Safety is paramount. We're talking about a highly flammable gas, so storage and transportation, those are big concerns.
I mean, even getting past the whole explosion risk, isn't hydrogen, like, really difficult to store?
It is. Hydrogen atoms are incredibly tiny. To store enough of it to be useful, you either need immense pressure or you have to keep it super cold as a liquid. Both of those options require specialized and expensive infrastructure.
And on top of all that, there's that invisible flame thing. If there's a hydrogen leak, how do you even know?
Leak detection is a major focus. We need sensors that can quickly and reliably detect even tiny hydrogen leaks. And then there's the issue of embrittlement.
Right, the excerpts mentioned something about that.
Hydrogen can actually make some metals brittle. Those tiny hydrogen atoms, they can sneak into the metal structure and weaken it. So we'd need to rethink pipelines, storage tanks, a whole lot of infrastructure.
Okay, yeah, suddenly this is feeling less like a quick fix and more like a massive undertaking.
It is a massive undertaking. There's a lot of excitement about hydrogen's potential, and rightfully so, but widespread adoption, it's still a long way off. Realistically, we're probably looking at decades.
So it's a marathon, not a sprint.
Exactly. And it's crucial that we approach this with a clear understanding of both the potential and the challenges. It's not a silver bullet, but it's definitely a fascinating piece of the puzzle.
A puzzle that we're only just starting to put together. Well, I have to say, I've learned a ton from this deep dive. Hydrogen, it's a lot more complex and intriguing than I ever imagined.
It always seems simple at first glance. but the deeper you dig, the more fascinating it gets.
And speaking of digging deeper, for our listeners, those Wikipedia excerpts you sent in, keep exploring. There's a whole universe of hydrogen knowledge out there just waiting to be discovered. Until next time.